my laboratory
let's
success
go for
series, and
one
we
here.
are going to
I
be
know.
looking at
Must
great
be.
graphs.
Did you hear that
Before we
here?
get into it, I'm going to
It
ask for your
feels
support.
so
You want to
good.
feed the penguin
There's
by clicking
actually
those
a
buttons
kidding me.
below. You know it feels good.
One lion.
Another way you can feed the penguin is by supporting Audible. So
Well,
if
then
you
you
are
already have
interested in
enough.
downloading a free audiobook of your choice, click the link below.
Isn't it
And thanks
right?
to Audible for supporting the Penguin Prof channel.
There isn't nothing.
So you want to stay tuned.
Stay
We're going to do a
tuned.
lot
We're
of
out of
good
here.
graphing
All right,
here. This
stay
is going to be a
tuned.
quick overview of the
Stay
different
tuned.
types of
Actually,
graphs. I want to say at the outset that
It's a
this
great
is
number
designed
out
for
one
biology,
because
physiology, sort of
I
natural
know
science
you have
students.
their
This is
shops
not
there,
geared
number
for example, a statistics class.
And what?
We are going to look
I
at the
know.
essential components of a
Years
graph and how
old.
to do graphs
Years
by
old.
hand.
I'm 20 years
Okay,
old.
so let's
I
look
know,
at the
isn't it
major
great?
types of
Pie
graphs we are
chart
going to
is
come
actually
into contact with.
pie
The
charts
first is a pie
actually used
graph or a
70s,
pie
80s,
chart.
and 90s.
These are pretty
Green.
self-explanatory. Generally, what
I
you're going to
got him.
see in a
What
pie
did
chart
you
is a
think you were?
simple legend
Jason
which
passed
will
me.
explain
I'm
what
sorry.
the colors
We fight
represent,
again.
and that's
Oh,
pretty
everyone
much
bread
it.
here.
Next, we've got bar
I have a
graphs,
bread.
and bar graphs
Sorry,
are
we find
used to
bread
compare
here.
different
I don't think
variables
so,
and
but not
categories
sure is
like this
beautiful.
one. You notice that the bars can be reordered
I have
and
it
they
on.
do not
You'll
touch
find
each
that
other.
right there.
Bar graphs
When
are
you
also
have
useful
her?
for looking
No,
at
I
things
don't
like
like it.
this, where you have
No,
a
I
single
don't like
variable
it.
or
I
a
know
summary
right there.
variable, like a
No, it's
mean,
not getting
among
back.
different
I'll be right
groups
back
over
before you know it.
time. And here you
All
can see
right,
it's really easy
everybody.
to look
You
at
are
positive
moving,
and
okay?
negative changes. This
It's
is
all
the
right there.
GDP for
Oh my
Cuba.
God,
And by the way, I have to mention we just got back from a project
No,
in
you
Cuba, and it
wasn't.
was an absolutely
Over
amazing place.
But
Okay,
you
next we
didn't
have
need to
a
the cover.
frequency
I don't
histogram.
know. Isn't
This
that
is used to
great?
show a
Triple
distribution
cover.
of
She
variable
lives.
values. So
I'm
instead of
reduced.
showing
I
different
got the news
categories like
liking.
before we had the
Looks
different
like
types
the
of
seven
trash,
of blade.
this is a
You know.
single variable,
Two
and in
can
this
play
case
this
it's height.
game.
And we're looking at the
Oh,
distribution
she's
of
good.
different
But I
heights
want
that were
you
observed in
can
a
be
particular
here
species
for
of
us.
pine.
You're
And you
this
notice
rat.
that bars
But
can't be
imagine over
reordered
yet.
and they touch
The
each other.
great and
A
powerful.
scatter plot
Oh my
is
God,
used to
look
show
here.
correlations between two variables. Usually
You're
we're
here.
looking to see, is
Excuse
there a
me?
relationship
Is it
between these
Alice?
two variables? And
Yes?
you'll often see a
You haven't
regression
heard
line
one.
that is shown
No, it
to
wasn't in here.
express that relationship if there is one.
I
A
don't know.
line graph
I
is
know.
something that we're going to be looking at in more
Here.
detail, and it shows you
What?
a relationship
No,
between
it
a
wasn't.
dependent and an
Alice,
independent
nor
variable.
happens
We
all.
are going to
Nor
get
ever
into that
will.
in just a second.
Not too
In
long.
some
You
line
have a
graphs, you will be
points.
asked to
We'll find
connect the
points
data
in our
points like
graph.
the one shown
How
here, and
graphics?
sometimes
Yes,
you will be
I
asked to
know.
draw a
Isn't
line
it
of
great?
best fit, and we're going to be
As
doing
long
that here in
as the
just a
detectives
moment.
are one who sticks.
So we are
And
going to
mine
make a line
has
graph
a
by hand.
costume.
Yes, this is old
Over
school,
from the
but I do
costume.
require my students to
Only
do this
have to have
during their
one
lab
here.
period. It's
For
just
what?
a good skill
Where
to
do I have
have.
it all? I don't
Item
know.
number
Isn't it
one,
great?
use a ruler and
Over
graph
place.
paper. Just
There's a
do
right
it,
here.
okay? The next thing
I
you're going to
know
need
here.
is a
Or
descriptive
has
title.
more.
This should be a
There is a
phrase
cat
that
here.
tells the reader,
Accident
what
here.
is
What is
this?
this?
It should answer
This
that
is
question. So the
actually
graph should
revolver.
stand alone. You should be able
Funny.
to look at the graph
If
and
I
with the
was
title and the
place
axes,
your
explain to
relationship.
someone else what the
It
fuck
wasn't me
is
here.
being shown
I
here.
know. Isn't it
You
right
can tell
here?
by looking at
All right,
these.
gee.
There's
Oh, man,
no
Washington,
way to
don't
know
let
what
bad
the data
titles
actually represents here. Once you have a
this.
title,
I
you're
think
going to
actually
need a
this
legend
here.
if you have multiple data
This
sets.
is her
So
election.
that basically
Don't
just
let me hear
shows
her.
if you have
I
different
don't know.
lines
Isn't it
or
right?
different
You
bars,
don't have me here,
what
Lover.
does each
Oh,
line or
man.
each bar
Looks
represent?
lacking here.
Next, we
Well,
have
I have one here.
axes.
Hey,
Each
kids.
axis has a
Hello,
title,
kids.
and it will
You're
have units.
here.
And so you
Hello.
should be able to read blank measured in
You're
blank. So
one.
the axis title is what is
I
being
don't know.
measured,
Isn't
and the
right?
units in parentheses
I
are
think
the
everyone
units of
here.
measure. So
Well,
time
do.
measured in seconds,
Do.
mass measured in grams, etc.
I
You
know,
need
right?
both of those. There are a few
Come
exceptions.
on!
The most notable is
You
this
stupid
guy,
Elliot!
absorbance. You'll see
My
sometimes
stop!
it will be written
My
as
hand
just a
stop!
capital A. It is unitless. So if you are measuring absorbance in a spectrophotometer, you don't need units there. But everybody else is going to need units. All right, so which axis is which, and what do you plot in each one? The x-axis is where the independent variable goes. That is the thing that changes or the thing you are manipulating. The y-axis is the dependent variable. That is the thing you are measuring. So some examples will probably be helpful here. The relationship between the sales of ice cream and ambient temperature. So as the temperature changes, how many ice cream cones do you sell? The relationship between soil nitrogen, how much nitrogen is in the soil, and how tall did the tomato plants get? And as you look at the change in absorbance, you're actually looking at the production of product in a reaction that is catalyzed by the enzyme alkaline phosphatase. So absorbance is what you're measuring, that goes on the Y, and time is on the X. Okay, how to make a graph. The first thing you're going to do is collect the data and determine the best kind of graph to use. So I am going to be graphing the data from the What is a Standard Curve video. If you want to see that, I'll go ahead and put that link below.
Check it out.
We're going to determine the range of the data sets. So you need to look at the data that you have and then look at the space that you have in the graph. So on this particular graph, I've got 21 squares, and I'm going to plot the concentration from 0 to 50. Just because that is more convenient. So I'm going to consider my range 50 milligrams per deciliter. I've got 20 squares that I want to use, and if I do that division, I get 2.5 milligrams per deciliter per square. So that's what each square represents. Now, I am making a big deal about this, but the truth is, all of you watching this, you would just do this without thinking. Okay, you would just naturally figure out what the range is, how many tick marks you want, and you would put the values in like that, right? You don't really think about it. The reason why I mention how to do this is because students hate it when the numbers get ugly, as they do in our absorbance values. So it's the Y that is ugly. I've got 16 squares, and I've got to figure out how to graph my absorbance data. Now, 0.0075 is very, very close to 0, so I'm going to use as a range from 0 to 0.037, and I've got 16 squares to do that. So what I do is I divide the range by the number of squares that I have. That gives me 0.0023. That number is kind of awkward, so I'm going to round up and use 0.003 per square. So what I'm going to do is start with the smallest number. In this case, I am using 0, even though that is not one of my data points, but it is very close to 0.0075. And then you add the increment that you just decided to use. Now, just for clarity, I'm not going to mark every single square on the Y. I'm going to use every other square. So you're going to notice I'm going to go up. My next point will be 0.006. Again, I don't want to clutter the Y, so I don't need to label every single one. I did actually label quite a lot here just so you guys could see. And I go all the way up to 0.042. That extends beyond my data set by a little bit. And that's okay. It's going to look good.
What are you doing?
Now I'm going to plot the data. So what I do is I look at my data and I take that first point, the 10 on the X, 0.0075 on the Y. So I'm going to go up on the X, and then I'm going to find 0.0075 on the Y, and that's where my point goes. And I'm going to do the same thing for the rest of my data points. And ta-da! There you go. Those are my points plotted on the graph. Oftentimes, you will be asked to draw a line of best fit. I'm going to do that here, and you just need to eyeball it and get a ruler. And Flops the Penguin is here to remind you, don't extrapolate. That means don't take the line beyond your data points, right? You don't know what happens outside of that range, so don't extrapolate the line. Next, I'm going to show you how to measure the slope of a line. So what you need to do is pick 2 points on the line, and I just picked at random these two, and boy, does this bring back memories. Oh yes, it does. The slope of a line is simply the rise over the run. That's the easiest way to think about it. It is the change in Y divided by the change in X. So you've probably seen it written like this. So for our line right here, and the 2 points I've selected, I'm going to take 3 minus -1 divided by 4 minus -2. And when you do the math, you get 4/6. which is 2/3. And that's the slope. All right, that was a trip down memory lane, right? The last thing is you want to think about the results, obviously, and discuss them in your results section, in your lab notebook, or in a lab report. All right, we've got some special tips here at the end. Sorry, it's not funny, but I'm desperate. If you have a datum at the origin, you should graph it. And if you don't, then don't. By the way, the word datum is the singular of data. So that is actually how you use it. Next, what about outliers? What are you going to do with data points that are way out of range compared to everybody else? Usually they are due to experimental error or just regular variability. The reality is, in research, whether you retain or exclude an outlier depends on statistical tests. My point is you don't get to choose. Okay, things like Q tests and so forth are what we use to determine whether or not we keep them. In an educational setting, I would say ask your professor about your outliers. Breaking your axis. So a lot of times you end up in a situation like this, where your data set will contain some values that are really far away from the rest. And when that happens, the best thing to do is put a break in your axis. And I'll show you a couple different ways that we show that. And probably the best way for me to show you why you would want to do this is to show you the same data set expressed with and without the break. So here you see the data set with an axis break. Now I'm going to show you the same set of data, and I do not break the axis. Now you can see that because that series 4 is so out of range compared to the others, what basically happens is you don't get to see anything in the other data sets. So this is a great example of when you would want to break your axis. The last thing that we're going to do is talk about percent change, because this is something that many times you will find yourself having to graph. And there is actually a way to calculate percent change. You're going to take the new value minus the original value divided by the absolute value of the original value. Sometimes that's called a modulus. And whatever the number is, whether it's negative or positive, you make it positive. That's all an absolute value is. You can think of it as the distance from 0 on a graph. Okay, and that is going to give you the percent change. And the best way for me to show this is to give you a couple of examples. So here I've got heart rate before and after exercise. So I take my new value minus the original value divided by the absolute value of the original value times 100, and that's going to give me an 81% change. Notice that's an increase. In example number 2, my original value is higher than the new value. And I'm pointing this out because it's really important to notice when the value is negative, that means you had a negative percent change.